Okay, the question is asking us to solve a pair of simultaneous equations using a graphical method. So that means they want us to graph the lines, see where they intersect, and read the x and y values, which is the solution. It's not the most efficient way of solving simultaneous equations. It's not even going to be the most accurate way, but they're asking us to do it, so let's do it. And I'm going to shortcut this whole process. So rather than manually work everything out, I'm going to get Excel to do a lot of the hard work for us. So open Excel. We need a bunch of x values. Let's start at -5. And the next cell along, we're just going to take the previous cell and add one and then spread it out. And we've got a bunch of x values. Perfect. So underneath that, let's work out the quadratic values. So the first one is going to equal the cell above, squared, -8 times that same cell, and then add 9, and we've got a y value. Underneath that, we'll have the straight line. So we can say that equals 2 times the x value cell plus 1, and we've got a y value for the straight line. All right, just select those two, spread it along, and we've got all the y values. Thank you, Excel. Now we select all of the data, and we go to insert, and we're going to insert a scatter plot, but this scatter plot, we're going to use curved lines to join the dots. And perfect, we've got a chart. It shows us the quadratic, it shows us a straight line, and it shows that they intersect in 2 places. All we have to do to finish the question is read what are those 2 places. It's a little hard to read because of the scale, the lack of data. We couldn't be very accurate in reading that. So let's change things up a little. Let's just do a graph from 0 to 10 because that covers the intersection points, and that will be helpful for us. Okay, so that looks a bit better and it looks possible to read. Maybe we can get an estimate of what those points are. So let's copy that and bring it back into OneNote, make it larger, and now let's have a look at where those intersection points are. Well, they're not right on a whole number. You'll notice that it's below 1 on x and it's above 9 on y. So let's look at the first one. We know what the points are because we can see what they are in the table. And so the quadratic at 1 is 2, so it's 1, 2, and the straight line at 1 is 1, 3. And we can see that the intersection point is less than 1, and it's going to be between, the y value is going to be between 2 and 3. So let's just say it's approximately 0.9 and 2.6. Why not? It's a good enough guess as any. Let's go to the other one. We see that the intersection point is actually above both of those points at x equals 9. So the straight line point is 19. So we're going to say that, let's just say that that intersection point is 9.1, a little more than 9, and a little more than 19. Let's just go 19.1. Right, and that gives us our solutions. X is approximately 0.9, y is approximately 2.6, or x is approximately 9.1, y is approximately 19.1. We're done. That's all the question asks us to do. But let's solve that in a better way and check to see how accurate we are. Okay, so to solve it a better way, we're going to grab those 2 equations. We're going to say, how can we solve it? Well, y equals one of them, y equals the other one. So let's do substitution and just say 2x plus 1 is equal to x squared minus 8x plus 9. All right, we can rearrange that to make it a quadratic. We take the 2x plus 1 and over to the other side and subtract it. And we'll get x squared minus 10x plus 8 equals 0. All right, can we do it by inspection? Multiplies to 8, adds to -10. There are no numbers that we can work out easily that would do that. So let's use the quadratic formula this time. So x equals -b plus or minus square root of b squared minus 4ac over 2a. If we put the values in, we get 10 plus or minus the square root of 100, which is 10 squared, minus 4ac, so 4 times 1 times 8 is 32, and divided by 2a, which is just 2 times 1, which is 2. And that equals 10 plus or minus square root of 68 over 2. All right, we need a calculator to help us with that. Grab a calculator, let's punch in 10 plus 68 divided by 2, and we get 9 point, well, let's go 1, 2, 3. That's nice. And let's put in 10 minus root 68 over 2, and its x is approximately 0.8769. We'll stick with that for the moment. All right, and we need y values, right? So we can take those x values and put them into any of the original equations to find out what the y values are. Obviously, one of those is a lot easier to put the x ones in, and that's the y equals 2x plus 1. So we're going to put our x values into that one to find out what the y values are. Y is equal to 2. Let's use the 9.123 plus 1, but I'm going to use the whole amount on my calculator and get 19.246 approximately. All right, and we're going to grab the 0.8769, multiply it by 2, add 1, throw it in the calculator, and again I stored those values in a variable, so I'm using that variable to be really accurate, and I get y is 2.754 rounded. 3 decimal places. Okay, so here we have the solutions that were done algebraically, and we can see that, well, we're kind of close on the x values. 0.9 is, if you round 0.88, you get 0.9, so that's nice. Our y was a bit off, our reading of it. As a guess of 2.6 is a little below 2.75 if you rounded 2.75. It would go up to 2.8, so we're off by 0.2. And the x of 9.1 was close to 9.12, and then 19.1 is not that close to 19.25. But we did okay. That shows you two techniques: what the question asks plus solving with the quadratic equation. And you can see that solving graphically is not that accurate. You probably we can't be more accurate than just the units place in this particular case, if we're lucky to the first decimal place. That's it.